I think I should start preparing for my chemistry test tomorrow. Hey Dad. I am going to Uncle Matt's chemistry lab. He's going to help me study for my test. Your Uncle Matt doesn't know anything. I am going to teach you, son. So what do you need help with? Thanks Dad, but I think I'll go to him. Hey Uncle Matt.
Oh, hello Brian. What are you doing here?
I want you to help me with my chemistry test tomorrow.
Sure, let's go to my office. So what is this test on?
Enthalpy and entropy.
So enthalpy is a thermodynamic quantity equivalent to the total heat content of a system, equal to the internal energy of the system plus the product.
I did not get any of that.
Okay, in simpler words, enthalpy is a measure of the total energy of a thermodynamic system. It includes the internal energy, which is the energy required to create a system. But before I tell you the rules to determine the enthalpy change, do you know what exothermic reactions and endothermic reactions are?
Yes, exothermic reactions are the reactions in which heat is released, and endothermic are the ones in which heat is absorbed.
Very good. Remember some of these facts. The activation energy is required to start reaction. Delta H is the change in heat energy between the products and the reactants.
And the unit for delta H is joules, kilojoules or calories.
Good job. Now let me ask you a question. Will the value of delta H be positive or negative for exothermic reactions?
Negative, because the energy needed for the reaction to occur is less than the total energy released.
Excellent. Now what about the value of delta H for endothermic reactions?
Positive, because the energy needed for the reaction to occur is more than the total energy released. Does that mean if you double the coefficients in an equation, then the value of delta H is multiplied by 2?
That's right. Here's an example.
So we multiply H2 and O2 by 2, and the product side gets multiplied by 2 as well.
That is a true statement, but do not forget to multiply the delta H. Remember, this law is commonly applied to phase changes, although it is true when you reverse any thermochemical reaction.
Give me an example for this one too.
Here you go.
So basically, the signs for delta H gets reversed.
Another way to look at it is to remember that delta H is a state property, so it must be independent of the path of reaction.
So if reaction 1 plus reaction 2 is equal to reaction 3, then delta 3 is equal to delta H of 1 plus delta H of 2.
Heat reaction is equal to the heat formation of products minus the heat formation of reactants. Let's do an example. The combustion of methane gas. Heat of formation of CO2 plus 2 times heat of formation of H2O minus heat of formation of CH4 plus 2 times heat of formation of O2.
So, the heat of combustion, that is, the heat of reaction, is minus 802.3 kJ per mole of methane.
Notice that the value is negative, so the reaction gives off heat as expected for a combustion reaction. Entropy is a thermodynamic property that can be used to determine the energy not available for work in a thermodynamic process, such as in energy conversion devices, engines. The following are in order from least to most amount of entropy.
Solid, liquid, gas.
Let's think about it. Solids have minimum entropy and maximum order, whereas liquids have maximum entropy and minimum order. The greater the disorder or randomness in a system, the larger the entropy. The entropy of a substance always increases as it changes state from solid to liquid to gas. When a pure solid or liquid dissolves in a solvent, the entropy of the substance increases. When a gas molecule escapes from a solvent, there is an increase in entropy. Entropy generally increases with increasing molecular complexity. Reactions that increase the number of moles of particles often increase the entropy of the system. Here's a question for you, buddy. Which of the following reactions results in the largest increase in entropy? A. CO2-CO2, B. H2 plus Cl2 to HCl, C. KNO3-KNO3.
All of the reactions result in an increase in disorder, but A, in which CO2 moves from a solid state to a gaseous one, represents the largest change in disorder. We can calculate entropy using a table of standard values in much the same way that we calculated enthalpy earlier.